asked you to, what strategies that you have for adding and subtracting integers without counters or a number line. Okay, so tell me, what did you guys come up with?
Minus.
Not quite. Somebody else?
So I have a strategy. If the question was -5 minus 3, what you could do is you could take the numbers by themselves and you take their signs and put it on top. So like -5, you put like a little negative sign above 5 and a little negative sign above 3. And if it's the same, then you add. But if it's different, you subtract.
There we go. See, that's what I was trying to get to without saying all that other stuff.
Yeah.
When your signs are the same, you add, right? When they're different, what do? We subtract. Now tell me about the sign of the answer.
The bigger number.
Well, the answer on the same sign is just same.
Yeah. But the different sign is the one that's bigger.
That's right. Different, big number wins. Okay, and what do I mean by that? I mean like -20 plus 3. Okay? Are your signs the same or different? They are different. Therefore, we're going to subtract. So what's 20 minus 3? 17. And now, don't look at the sign, but what number is bigger, 20 or 3? 20. So his sign wins. That means it's negative. Okay? Why do you think it's important for us to come up with what I call like a shortcut, kind of like rules? Why is that important? Come on, guys. Why is that important? Well, yeah, because are we going to always want to use counters and number lines? No, and also counters and number lines are not going to work for what kinds of numbers?
Gigantic numbers.
No.
10,000.
No. What kind of numbers are counters and number lines not going to work for? Decimals and fractions. That's right, because I can't show part of a counter. Okay? Is everyone good? Okay. Today, we are going to be talking about multiplying and dividing integers using a model, okay? And I'm just going to put this out there that this can get a little bit confusing with the models. So I promise at the end, we're going to come up with basically something like this, but for multiplication and division, okay? So just hang with me on these models, okay? So first of all, I want you to think about 5 times 3. Think back to 3rd grade math. What did that mean? What does 5 times 3 mean?
5 times 3.
5 times 3.
5 plus 5.
There we go. I was looking for the word groups. It means 5 groups of 3, right? Are you writing? If I'm writing, you're writing. So that would mean I have 5 groups of 3. And then in your 3rd grade classroom, 5 groups of 3 would have been 15. Does everybody catch that? Okay. Now we're getting a little bit more advanced, and we now have. Does everyone know that that dot sitting right there means multiplication?
Yes.
Okay. So how else besides 6 times -2? What else could I say?
6 times negative.
Perfect. So that means I would have 6 groups of -2. And how much do you get? -12. Everything cool so far?
Yes.
Okay. Let's look at the next one. What does that mean? -3 groups? -3 groups? How can I do -3 groups? You can't, right? So I want you to think of what else that sign could say besides negative. No. No.
Dash.
No. Think about when we talk about this.
Absolute value.
There it is. Opposite. That was the word I was looking for. 3 groups of 4. So that means, okay, I need 3 groups, right? There's 2 ways to think about this, okay? I can do 3 groups of 4, right? 4, 4, 4. How much would this be? 12. But then I need to take the opposite, so what would that be? Negative 12, right? Or I could do 3 groups of what? Negative 4. That's right. Do you see what I'm saying? So the first way I did it a positive 4, but then I took the opposite at the end. Here, I did the opposite in the beginning. It doesn't really matter, but if you say opposite, you have to change, you have got to change one, okay? Is everybody with me there? Okay? Now, you've got a little space on your paper underneath, and you've got space to draw one more rectangle. You could probably draw one kind of small right here. Draw one more rectangle. And this time I want you to put negative 5 times negative 2. Does everybody also understand that numbers sitting next to each other like that with parentheses also means multiplication?
Yes.
Okay. If you weren't sure about that, on my wall over here where it says invisible math, do you see where it says multiplication signs? There's all those different ways that you can see multiplication, okay? So you might see it with parentheses. They might both have a parentheses like this, or just one of them, all right? So now, let's say what this means. Well, I can't have negative 5 groups of negative 2, right? So what would you say? The opposite, y'all, my smart board.
You should draw
The opposite of what? Of 5 groups of negative 2. So let's go ahead and do 5 groups. There's 5 groups, and put 2 negatives in each one. How much do you have? Negative 10, but then I have to do the opposite, so that would be what?
10.
Positive 10. Or I could have done 5 groups of what? If I'm doing the opposite of 5 groups of negative 2, then that really means 5 groups of 2. Which would still be 10. Does that make sense, you guys?
Yes.
Okay. Questions so far on multiplication? Okay. Next page, we're going to get into division. And we're actually going to go in the reverse order, because if you look at the first one compared to the last one, the last one's a lot easier. So we're actually going to start at the bottom. Okay? So let's start with number 6. What does that mean?
It's 15, not negative.
Okay, so negative 15 divided into 5 what? Groups. Okay? Okay? Do you think I can do that easily? Negative 15 and put it into 5 groups?
Yeah.
Sure. 1, 2, 3, 4, 5. Now, let's pretend that you don't already know the answer. Because raise your hand if you already know the answer. Yep, I knew that. Okay. So now let's pretend that you don't. You can take negative 15 and just pass them out. Okay? What I mean is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And now you can see how many are in each group, which is 3 what? Negative 3. So negative 15 divided by 5 would be negative 3. Does everybody see that?
Yes.
Okay. Let's move up one. So now we have 20 divided by negative 4. What does that mean?
20 divided into 12.
Oh.
Opposite of the.
Yes. Okay, here's the thing. When you started trying to say it, when you were like 20 divided into 4 negative, So as soon as you knew there was a problem, then that told you that you were going to need to use the word opposite. So now you're going to say this means the opposite of 20 divided into 4 groups. okay? So I need 4. And I want the opposite of 20. What is the opposite of 20? Negative 20. So that means I'm going to put what? Negative. Okay? And now your answer is, what do you see in each group? Negative 5. Okay? Is everybody with me so far? Is everybody what's wrong? Okay? With what? Okay, now let's look at this one. Negative 10 divided by negative 2. Well, when you start trying to say it, you say negative 10 divided into 2 negative groups. That doesn't work, right?
Yep.
So what do you have to say? The opposite. Okay, so if I'm going to say the opposite, though, what I'm going to take the opposite of negative 10, right, divided into 2 groups. Okay, so I've got my 2 groups, but I need the opposite of negative 10 to divide it, right? Well, what's the opposite of negative 10? Positive 10. So now, how many are going to be in each group? How many? 5. Because the opposite of negative 10 is positive 10, and we're dividing it into 2 groups. And what's the answer? 5. Okay, so when we used the word opposite, right, we had to change it. We had to change the opposite of negative 10. Okay, or another way to look at this one would be if you had 2 groups and you took and put negative 10, but to get an answer, you would need to do the opposite. So the opposite of negative 5 would be positive 5. Yes. Okay. Now, I told you that the models are a little bit confusing. So now here's where we're gonna make this so easy. Okay. Here's what I want you to do. If you haven't already, up here I want you to write the answer. So negative 10 divided by negative 2 was how much? 5. 20 divided by negative 4 was what? Negative 5. Negative 15 divided by 5 was what? Negative 3. Now go back to the multiplication page. 5 times 3 was 15. 6 times negative 2 was negative 12. Negative 3 times 4 was negative 12. And then negative 5 times negative 2 was positive 10. Okay? So what I'd like for you to do, try to figure out with a partner, looking at what we just did, you're trying to come up with something that sounds kind of like this, like in general. When this happens, okay? But again, it's going to be for multiplication and division, and you're going to write it down here on the bottom. When, okay? Here at home, pause the video and try to figure this out first. Okay, so now we figured out that when the signs are the same, the answer is positive. Okay? When different, the answer is what? Negative. Multiplication, negative. With multiplication and division, it's actually way easier than addition and subtraction, which seems kind of counterintuitive to what we've learned, right? You know what I'm saying? Isn't normally addition and subtraction easier? Yeah, but when it comes to this is actually way easier. And I'm just going to write some problems up here. You don't need to write these down. We're just going to save them together, okay? Okay, so first, we just multiply or divide. Okay, so what's 5 times 2? No, what's 5 times 2? 10. And then are the signs the same or different? Different, so negative. Next one, what's 5 times 6? 30. Signs same or different? Different. 30 divided by 5? 6. sign same or different? Same, so it's positive. 24 divided by 4. 6. Sign same or different? Different. Do you see how that works?
Yeah.
Way, way easier, okay? Unlike, let's switch gears for a second. Let's go back to addition and subtraction, okay? If I have negative 3 plus 4, let me just put in some here. All right. First one, sign same or different? Different. Therefore, I'm going to subtract. And what's 4 minus 3? 1. And which one wins? Big number. So it's positive 1. Okay? Second one. Before I start tackling about sign same or different, what do I want to do with this? I want to turn it into addition. So I want to add the opposite. Now I can say, are my signs the same or different? Different. Therefore, I'm going to subtract. And which one wins? Negative. Y'all remember?
Yeah.
Okay. Better? Okay. All right. On the next page, we now have a couple of word problems. The hardest part about multiplication and division word problems is that they use a lot of the same words, and people get confused as to whether they're supposed to multiply or divide. The best thing I can say to you is ask yourself, am I listening for a total? Am I trying to get a total, or am I trying to get a part? Okay? And then that should help you, okay? Ethan burns 650 calories when he runs for an hour. Suppose he runs 5 hours. How many calories did he burn? So first of all, he burns calories. What's happening? Positive or negative? Negative, because burning means they're going away. So that would be negative 650 calories in an hour. They want to know how many in 5 hours. Multiplication or division? Multiplication. That's your first thing. Let's write our expression. So that would be negative 650 times 5. Okay? Sidebar. We will hardly ever write multiplication and division with an X. Anybody happen to know why? That's right, because coming soon to a classroom near you, when you see an X, it's no longer going to be multiplied, it's going to be a variable. And so really, we really stop using X's for multiplication. We're going to use the dot or the parentheses, okay? Okay. That's right. See? I was reading your mind.
I learned something about like 3 minuses equals to like negative.
Okay, so guys, what's the answer to this question?
Oh, burns 3,000.
Okay, so I could say he burns 3,250 calories. What about in this blank right here? What else can I put in the blank? Negative 3,250 calories. Can I say he burns negative 3,000 whatever?
No.
Why not?
Because that is interchange, like negative to negative.
That's right, because if I say burns and negative, that's a negative negative, which is positive. Okay? So be careful about that. Okay, let's look at the next one. Wave erosion causes a certain coastline to recede. What does recede mean? It means to go back, right? So that means if it's a rate of 3 centimeters each year, what's really, that would really be negative 3, right? Because it's coming back. This occurs uninterrupted for a period of 8 years. How many centimeters has the coastline eroded? Multiplication or division? Multiplication, again, because we're looking for the total that it has eroded. What would your expression be? Negative 3 times 8, which would be? Negative 24, right? Because 3 times 8 is 24. Signs are different, therefore it's negative. So it's negative 24 centimeters. Or, what else could we say? It lost or receded. Yeah. Okay? Pretty good? Okay, we're going to skip the next one for a second, and we're going to go to number 4. In Minneapolis, the high temperature in degrees Fahrenheit for 6 days in January were negative 12, negative 8, negative 3, 6, negative 15, and negative 4. That's why I live in Minneapolis. But anyway, what was the average temperature? Tell me about the word average. That is the mean, and how do we calculate that? That's right. Okay, so the video. And then tell me, over here, when you added, hopefully you made yourself a little T-chart like I've taught you guys. 6 should have been here, -12, -8, -3, -15, and -4 all should have been here. So then that meant your sum here was 6, right? What was the sum on the negatives? -42. And so when you put those two things together, what'd you guys get? -36. So that was your sum. So -36, and then you were supposed to divide by 6, which would give you -6. So now what would you say the answer is? -6 degrees. Don't forget it was degrees, okay? No negative numbers. All right, guys? Any questions? How are we doing? Better? Okay. So your homework is going to be the rest of the packet.